Yes. So we know that the perimeter of the circle is called as the circumference. Okay. And the circumference or the perimeter is given by the formula. Okay, what is this length called as? So this is the center.
Radius.
Yes, this is called as the radius.
Radius.
Right? Or I'll short form, I'll give it as R, radius. So the circumference is equal to, remember, 2 into radius into pi. We saw about pi in the last class, which is pi has a value of 3.14 usually. It actually never ends. It keeps going on.
3.14.
It keeps going on, but we'll just abbreviate or approximate it to 3.14 for easy, to make it easy. You can also use
22/7.
yes, 22/7. Okay, to make it more easier for you, because multiplying decimals is difficult, right? So instead you can use 22/7. So now 2 times we have radius into pi, or you can write it as 2 pi r. That is circumference is equal to 2 pi r. Now can you tell me what is 2 into radius?
Diameter.
Yes, 2 times the radius is, so radius into radius plus radius, one more radius is the diameter. So I can also write the circumference as pi d, or pi into diameter. Yes, Amogam, the value of pi is 3.14. It is a constant, it never changes. Okay, this is a constant, which means never changes. The value of pi is always 3.14 or 22/7. Instead of 3.14, you can also use 22/7 as a fraction form. That is not the exact value of pi, but it's the close form. Now let us, so we finished circumference. Next comes area of this circle. So the area of the circle is equal to, again we have pi into radius into radius again. Okay, so the formula for area of the circle is equal to pi r square. Pi r square, this is the radius, this is the formula for area of the circle, remember this. Okay, pi r square. In terms of diameter, so what is the formula for radius? Radius is equal to
2r.
r, this is only r. Radius is equal to d by 2.
D/2.
Yes, or d is equal to 2r, right? So instead of r, if I put d by 2 over here, so here I have r square, right? So instead of that, if I put it here, I can also get area is equal to pi d square by 4, not 2, because it will become d by 2 whole square, right? So 2 square is how much? 2 square is 4. So this is the same thing. Pi r square is equal to pi d square by 4. Okay, this is the area of a circle. Next, let's look at another figure. What is this? Which figure is this?
Semicircle.
Yes, this is a semicircle. Okay, so remember this is a semicircle. Now can you tell me the perimeter of a semicircle or circumference? In this case,
pi r square by 2.
not pi r square, perimeter. What is the formula for perimeter of a circle?
Diameter into pi.
Yes, diameter into pi. This time it is, or it was, for circle it was
Half into R pi.
For circle, it was 2 pi r. Yes. So for semicircle,
sir.
it's going to be, so this is only half of the circle. So it's going to be 2 pi r by 2 because it's half of the circle, which is equal to how much? Which is equal to pi r. This is the perimeter for a semicircle. Similarly, what is the area for a semicircle?
Half into pi r square.
Yes, very good. That is pi r square divided by 2 because it's half of the circle. Okay, this is the radius. This is the formula for area of.
Sir, your presentation is not seen. Even your voice is breaking, sir.
So it's seen, sir.
Varshit, I think you're having network issues, sir, because others can see it. I'm showing the whiteboard and my voice is clear or is it breaking?
Very clear, sir.
Okay, I think Varshit, just check with your internet. It might be a bit slow. Okay, next, the next figure we're going to see is this, where this side is the radius and this is also a radius. So which type of figure is this? Yes, this is a quarter circle, or you can, not only a sector, because this is the radius and this is the radius, and this is 90 degrees. Okay, this is 90 degrees.
The quadrant.
Yes, quadrant of a circle, or we can call it as a quarter circle, or we better call it as a quadrant. So here, this is also known as 1/4 of the circle. So I made a mistake in the perimeter of the circle. Can you tell me where is the mistake in a semicircle? Can you tell me where is the mistake? See, for a circle, this red color is the perimeter of circumference, right? This is the red color is the circumference. Now, when I cut the circle into half to get a semicircle,
So pi should be half.
This side is half, right? So this side is half of the circle, and this is pi r. But I forgot to add this part, the base. Yes, I forgot to add this part. Not only the curved part. The curved part is pi r, but I forgot to add the base. Yes. So this also should be added because this is also part of the boundary, right? So this pi r plus this is radius. If this is the radius, this is also the radius, which is plus 2r or plus diameter. So the final perimeter is equal to pi r plus 2r. Don't forget this is very important. Or you can take r common. You can say r into pi plus 2. Both are same. Anything. But the area remains the same. Remember, area remains the same because area is the space, right? That is the same. Next, perimeter of the quadrant. So quadrant is 1/4 of the circle. So this part, this red color, which I'm transcribing, this part is also 1/4 of the perimeter. So it is, what is the perimeter of a circle?
Pi r square.
No. Don't get confused between
Diameter r square pi. R into pi.
Not r into
Diameter
pi. 2 r pi. That is the, for a circle. Again, don't get confused between, yes, 2 pi r. Don't get confused between area and perimeter. So 2 pi r divided by 4 because 1/4 of the circle. This part is 1/4 of the circle, right? Because it's a quadrant or quarter circle. This plus radius plus this radius. That is the perimeter, right? So plus 2r. So I can cancel this 2. So finally I'm going to get pi r by 2 plus 2r. This is the perimeter of a quarter circle. Similarly, area of the quarter circle is 1/4 1/4 into area of circle. What is area of circle?
Pi r square.
Pi r square. So that is nothing but pi r square by 4. That is the area. Okay. This is the area. Okay. Now let's look at something different. So this is a circle. Now this is called as a concentric circle or a circle inside a circle, right? It's in layers. I don't think it's exact, but this is a center. The center is the same for both the circles. This is like the outer circle. This is the inner circle. A very common question that is asked in your Sainik is, I give a figure like this that tell you, find the area of the shaded region. So they'll shade this region. They'll ask you find the area of the shaded region. Whatever I have shaded. Okay, so now, can you tell me
So
how can you?
find the area of both the squares and then subtract it.
Yes, no squares over here, circles. So
Sorry, circles.
yeah. So you have one bigger square. Now just imagine that you're taking the smaller square outside. Sorry, smaller circle outside, right? So when you find out the area of this, that is taking up a certain area over here, right? So when you subtract this area from the total area, so this has a total area, and from this total area, if you subtract this smaller circle, you're going to get the remaining region, that is this shaded region, correct? So now let's do that. So let's say the first one is the outer circle is having a radius of r1. Okay, r1, and the inner circle is having a radius of r2. Now, what is the area of the bigger circle? Area of the first circle. Let's call this circle number 1, circle number 2. What is the area of the total, the big circle?
Pi r square.
Yes, pi.
Pi into r1 square.
Yes, r1 square, because it's not just r, this is the first radius, right? So r1 square. Pi into r1 square. Okay. And what about the area of the smaller circle?
R2 pi into r2 square.
Yes, pi into r2 square.
R2.
The smaller circle. Now, when I subtract this from this, I'm going to get pi r1 square minus pi r2 square, correct? So I can find out this region, that is the shaded region, is pi r1 square minus pi r2 square, or I can simplify to give pi into r1 square minus r2 square. Yes. If you want to simplify it even more, you know that r1 square minus r2 square, it is the same thing like the identity a square minus b square, which is equal to a minus b into a plus b. This is in the identity chapter. So you can write it as pi into r1 plus r2 into R1 minus R2. This is the formula for finding the shaded region. I hope everyone is taking down the formulas. Are you guys taking down the formulas which I've written?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Good. So this is the, I think we've covered all the 2D shapes. Any other 2D shapes that we've left? All right.
Rhombus.
Rhombus, so I gave you the formula. That is parallelogram. Same thing as a parallelogram, only thing the sides are equal. So you don't need to find length and breadth. The length and breadth are equal. So one more last thing in circle.
Trapezium.
In a circle, let's say you have a sector, okay? You have a sector with a certain angle theta. Now if you want to find the area of the sector, okay? You want to find area of the sector. Area
So
of the
area
sector.
of the circle divided by 4.
No,
Area
that
of the
is for
circle divided.
that is for quadrant. That was one quadrant. Quadrant means equal parts, right? 4 equal parts where the theta was equal to 90 degrees. But here theta is not 90 degrees. It could be something else. It could be 80 degrees, 75 degrees, whatever. So it is not a quadrant. You cannot divide it by 4. Or to give a better example,
Okay, sir.
imagine a sector like this, right? Where you want to find, this is theta. You want to find the area of this shaded region, area of this sector. So now there is a formula for this. All you have to do is again pi r square, okay? Pi r square theta divided by 360. Same thing as area of circle, pi r square, but theta divided by 360. So for example, let me say that, I'll give you an example.